So imagine you are sitting in the C-suite, right? You're staring down this performance dashboard, and it is just bathed entirely in green arrows.
Oh, yeah.
Every single metric is moving up and to the right.
Right, which is, I mean, that's the optimal scenario for an executive team.
Exactly.
That visual representation of momentum, it's usually a signal that a big strategic bet is finally paying off.
Right. And welcome to the deep dive, by the way. Our mission today is to, well, pull back the curtain on a pretty hidden conflict that's currently unfolding across modern business.
Mm.
We're talking about this direct clash between the efficiency gains driven by AI and these rapidly rising carbon curves.
Yeah, it's a huge issue.
It really is. And our goal here is to give you a clear shortcut to understanding the true underlying footprint of artificial intelligence. Because we really need to move past this, standard narrative of just productivity and speed and actually look at the physical cost of this technology.
Yeah, because that narrative is, frankly, it's often incomplete.
Right.
We hear constantly about the capabilities, right?
Yeah.
What the AI can do. But we rarely hear about the physical infrastructure required to actually generate those capabilities.
Exactly. And to frame this tension, there's this really grounded scenario from our source material today that I think perfectly illustrates what operators are dealing with right now.
Okay, let's hear it.
So picture a chief operating officer, a COO, reviewing that dashboard of green arrows we just talked about.
Right, the dream dash.
The dream dashboard. So this COO had recently overseen the deployment of a new suite of AI tools designed to optimize their entire logistics network. And the results were, they were immediate and staggering.
Wow.
The AI implementation lifted their supply chain efficiency by 12% in a single month.
Okay, wait, 12%?
Yeah, 12% in 30 days.
That is, a 12% improvement in supply chain efficiency in a month is not just an incremental gain.
No.
In a mature operational environment, finding even like a 1 or 2% efficiency gain is usually this grueling process.
Oh, yeah. Blood, sweat, and tears for a point or two.
Exactly. So a jump of that magnitude that fundamentally alters a company's margin profile.
It's a massive operational leap. We're talking faster delivery times, dynamically optimized routing, and a huge reduction in wasted labor.
Yeah.
So the COO is sitting there reviewing this triumph, right?
Yeah.
Totally validating the investment. And here's the catcher. The picture totally changes when they open a secondary dashboard.
Ah.
The one tracking electricity use and environmental impact across all their operations.
I see where this is going.
Right. The productivity metrics were surging, obviously, but the carbon curve was climbing right alongside them. The AI that solved all their logistical friction was, at the same time, completely blowing out their energy consumption.
Yeah. And that single operational snapshot, it really encapsulates this macro-level crisis that major organizations are just currently accelerating toward. We're looking at a landscape where companies are scaling artificial intelligence infrastructure as aggressively as they possibly can.
Yep.
And they're doing it because AI has transitioned from this, speculative innovation, like a nice-to-have, to an absolute baseline requirement for competitiveness.
You literally cannot defend your market share without integrating these tools today.
Exactly. You just can't.
And here's where the friction really emerges. It's when you overlay that aggressive technological scaling with rigid corporate climate commitments.
Right.
Organizations are basically trying to run a hyper-growth, incredibly energy-intensive technology on a completely fixed carbon budget.
Yeah, and the underlying issue there is the discrepancy in the planning cycles.
How do you mean?
Well, the energy demand generated by AI infrastructure, it's accelerating at a pace that most current corporate planning models they simply don't account for it.
Ah, right.
Think about it. Most major organizations have publicly committed to strict 2030 climate targets.
Yep, those big sustainability pledges.
Exactly. They've established these highly structured trajectories detailing, exactly how they intend to draw down their emissions year over year.
Right.
But because the power requirements for AI are compounding so rapidly right now, these organizations are finding themselves on a direct collision course with their own sustainability goals.
Wow.
The very technology they deem necessary for economic survival is actively threatening their environmental commitments.
It really creates this profound structural dilemma, doesn't it? Leaders are finding themselves in a position where they feel forced to choose between maintaining their market edge and, honoring their corporate responsibility mandates.
Yeah, exactly.
And I think to truly grasp the gravity of this collision course, we have to look past that isolated dashboard of the single COO and actually examine the global infrastructure required to sustain these tools.
You do.
Because the sheer scale of the energy demand we're dealing with, it requires a complete shift in how we think about computational resources.
It absolutely does. And I think the most immediate way to quantify that shift is by looking at the data coming out from Gartner.
Let's get into the numbers.
Yeah, and it's really important to frame these numbers not as like speculative long-term forecasts for the next decade, but as early, immediate signals of a systemic change that is happening right now.
Right. The timeline is what makes this data so critical for operators who are just trying to plan their next few quarters.
Exactly. Yeah. So Gartner projects that global data center electricity demand will experience a 26.4% jump in the year 2026.
In 2026, that is right around the corner.
Yep. And to put the raw figures on the table for you, that is a projected increase from a baseline of 447 terawatt hours up to 565 terawatt hours.
Wait, 565 terawatt hours?
Yeah.
I mean, when you look at a 565 terawatt hour load,
Yeah.
you are looking at the consumption profile of a major industrialized nation.
Exactly.
A whole nation completely dedicated just to running data centers.
It's massive.
It's like, okay, imagine a logistics company, right? They buy this massive fleet of high-performance supercars for all their delivery drivers.
Yep.
They do it to speed up delivery times, right?
Yeah.
To stay competitive. But they completely fail to realize that their local town doesn't have enough gas stations to actually fuel all these supercars.
Right.
You've got the performance, you've got the speed, but the underlying infrastructure, the carbon budget, is totally maxed out.
That is a perfect analogy. You're buying the supercar without thinking about the gas. And the trajectory steepens significantly when we look just a few years further out.
Oh, boy.
Yeah. By 2030, Gartner expects data center power demand to see 119.7% rise.
Almost 120%.
Basically. We're looking at a surge from 132 gigawatts up to 290 gigawatts.
Wow.
The infrastructure demand is effectively doubling in a highly compressed time frame.
That is just, I mean, it's wild. It's probably worth pausing here for a second to examine the actual mechanism behind those numbers.
Let's do it.
Like, why does this specific technological shift require such a massive influx of power? Because I think a lot of operators, naturally, they just assume that AI is just, the next iteration of cloud computing.
Right, like upgrading from local servers to the cloud.
Exactly, like moving to AWS or Azure. But the underlying computational architecture is fundamentally different.
It is.
Like if I run a traditional database query or a standard search, the system is executing a deterministic function. It's just locating a specific existing piece of data and retrieving it.
Simple, efficient.
Right. It's a targeted action.
Right.
But large language models, generative AI, they operate on probabilistic computing.
Right.
Every single time you input a prompt, the system is not retrieving an existing file. It is mathematically calculating the probability of the next sequence of data based on billions or even trillions of parameters.
Yep.
It's generating original output from scratch using massive continuous matrix multiplications. And that heavy computational weight, that is the core driver of this energy demand.
Exactly. And that structural difference in how the compute actually functions, it directly translates into the physical grid strain that the International Energy Agency, the IEA, is currently tracking.
Yeah, let's talk about the IE data.
Well, the IEA data provides this real-world reality check that these projections are already manifesting.
It's not just theory.
No, not at all. According to their reporting, in specific tech-dense regions right now, up to 10% of national electricity use is currently being consumed by data centers.
Up to 10%?
Yes.
10%.
I mean, that 10% figure is sobering when you actually map it against the rest of a nation's infrastructure requirement.
Oh, completely. Consider the full spectrum of what a national grid has to sustain, right?
Right.
Residential zones, heavy manufacturing, healthcare networks, transportation infrastructure.
Right.
To have a full tenth of that capacity absorbed solely by the servers processing data and running AI models, it just illustrates how deeply intertwined digital innovation has become with our physical energy resources.
Yeah, you really can't separate them anymore. And for leaders navigating this environment, the takeaway here is pretty stark.
If you build your operational strategy without factoring in these early signals from Gartner and the IEA, like if you just assume the energy footprint of AI is somehow magically going to optimize itself over time, you are going to drift completely off your 2030 climate trajectory.
Yeah, you'll blow right past it.
The risk is waking up in 2 years with this highly efficient, totally AI-driven supply chain, but a totally derailed corporate carbon budget.
And the worst part is, because carbon budgets are cumulative, by the time an organization realizes they've deviated from their trajectory, the damage to their ledger is already logged in.
It's too late.
Exactly.
Which I guess brings us to the operational pivot. How do organizations actually manage this? Because we can't just unplug it.
Right.
The advantage here, though, is that leaders don't actually need, a deep engineering degree to solve the accounting problem.
No, they don't.
You don't need to understand the intricacies of neural network architecture to manage the energy cost. You really just need a practical, simple way to understand how AI actually incurs these carbon liabilities.
And the source material provides a highly effective framework for demystifying this exact process.
Okay, lay it out for us.
It breaks down the energy cost of artificial intelligence into two distinct operational phases: training and inference.
Training and inference. Okay, let's translate this into standard operator terms,
Okay.
standard accounting concepts, because I think this is where leaders can actually assert some control.
Absolutely.
We have training, which effectively functions as the CapEx,
Yeah.
right, the capital expenditure.
Right. The training phase represents the heavy, upfront computational lift that's required to build or fine-tune a model.
Yeah.
When an organization decides to train a large-scale AI system, they are feeding it massive data sets and running thousands of specialized processors at absolute maximum capacity for weeks, sometimes even months at a time.
Wow.
So it requires an extraordinary, highly concentrated surge of power upfront.
It's literally the digital equivalent of constructing a massive manufacturing facility.
Perfect way to look at it.
You are pouring the concrete, you're erecting the structure, and you're installing all the heavy machinery.
Yep.
But because it is such a massive, highly visible event, organizations are generally quite good at accounting for it, right?
Usually, yeah.
When a project of that scale is approved, the CapEx is highly scrutinized, and the associated carbon cost is usually factored right into the sustainability ledger. The organization knows they're taking a major hit to their energy budget right up front.
Exactly. The transparency of the training phase makes it manageable from a planning perspective.
Yeah,
You know it's coming.
right.
The real systemic risk, like the hidden operational trap that resides entirely in the second phase, which is inference.
Right. Inference is the OpEx, the operational expenditure.
Yes,
And this is the phase that I think requires just ruthless monitoring.
it does. Because inference is the everyday cumulative energy cost that occurs once the model is actually deployed.
Right.
It happens every single time the system is
Look,
utilized.
it's a single time.
Every single time. Every time an employee uses a generative tool to draft an email. Every time an automated workflow categorizes a customer service ticket. Every time a dynamic algorithm recalculates a delivery route.
Wow.
That continuous, ongoing execution that is inference.
So going back to our facility analogy, if training is the capital cost of building the factory, inference is the operational cost of running that machinery 24/7 for every single minor task.
Yes, and this is precisely why inference acts as a silent budget killer.
Because it just hums in the background.
Exactly. An organization can budget really carefully for the construction of the factory. But if the machinery is constantly spinning up for thousands of microtransactions every minute of every day, the compounding energy draw will inevitably eclipse those initial estimates.
And the danger really lies in the user experience, doesn't it?
What do you mean?
Well, inference is completely frictionless for the end user.
Oh, true.
From the perspective of an employee or even an automated system, you send a prompt, and a second later, boom, you receive a highly sophisticated output.
Right, it feels like magic.
It does. The user does not experience the computational weight of those matrix multiplications happening on a server farm somewhere hundreds of miles away.
No, they don't see the power draw, they don't hear the cooling systems engaging.
Exactly.
And this brings us right back to the chief operating officer reviewing that logistics dashboard from the start.
Right.
When that organization implemented their AI supply chain tool, the initial training phase, the CapEx that was likely approved and accounted for.
Right. They budgeted for the build.
But once the system went live into production, every dynamic adjustment to a warehouse inventory, every single real-time rerouting of a delivery truck generated an inference cost.
A constant drip of carbon.
Yep. That continuous, invisible hum of computational activity is what drove the electricity usage up and compromised their carbon targets.
Because the efficiency and the emissions, they're locked in a closed loop.
They are.
You are achieving the operational gains, strictly through constant energy-intensive computation. You can't just isolate the productivity from the power draw. They come together.
Which forces a strategic reckoning.
Yeah.
We've established that AI is a competitive necessity, right? Meaning we can't simply revert to legacy systems.
No, you can't put the genie back in the bottle.
Right. But we've also established that the compounding cost of inference will inevitably breach fixed carbon budgets if it's left unchecked.
So the question then becomes one of practical management. How do organizations actually manage this collision course?
Well, the source material advocates for a very specific strategic pivot to manage this.
Okay.
Organizations must transition their view of AI and integrate it directly into an ESG framework.
ESG, environmental, social, and governance.
Exactly. Moving AI out of the specialized kind of isolated domain of the IT department and firmly into the purview of ESG management forces a necessary standardization.
That makes a lot of sense.
Historically, AI has been treated as this protected category of innovation, right? Like a somewhat opaque technological asset that's allowed to operate outside the bounds of traditional resource management.
Oh, completely. We tend to give emerging technology a total blank check because the focus is entirely on just discovering its capabilities. We just want to see what it can do.
But applying an ESG lens removes that protected status.
Right.
When you operationalize AI within an ESG framework, it ceases to be a specialized innovation. It simply becomes another measurable operational input.
So it becomes structurally identical to how a business manages, say, its raw material supply, or its commercial real estate footprint, or its fleet logistics.
Exactly. And once it's categorized as a standard operational input, the organization can actually apply rigorous business discipline to it.
Right. You can actually manage it.
Yeah. The usage can be measured, the carbon footprint can be allocated to specific departments, and the entire system can be optimized.
So the conversation shifts from, we just need to deploy AI everywhere to remain competitive to, wait, what is our specific carbon budget for inference in Q3, and how are we allocating that budget across our divisions?
Spot on.
But the challenge there, of course, is the operational friction of implementing that level of visibility.
It's not easy.
No, it's not. Transitioning from a mindset of limitless technological deployment to a mindset of strict carbon allocation that requires really robust tooling.
Yeah.
Like if a marketing division spins up an automated generative campaign, they need to be able to see the real-time carbon cost of that specific inference load right on their departmental ledger.
Right.
And most organizations currently lack the granular internal accounting necessary to track the carbon footprint of an individual API call or prompt.
They do. Building that infrastructure requires bridging a pretty big gap between operations, finance, and sustainability teams.
Cross-functional nightmare sometimes.
It can be, but once that visibility is established, it enables a critical discipline, which is right-sizing the models.
Right-sizing the models. Okay, unpack that.
Well, currently, because AI is not treated as a finite, carbon-heavy resource, organizations are utilizing massive, highly complex large language models to execute relatively simple tasks.
I see. We are essentially using an industrial hydraulic press to crack a walnut.
Exactly.
Like if you just need to summarize a basic internal document or, I don't know, run a linear data sort, you do not need a trillion parameter model calculating the probabilistic outcome of every single word.
No, you don't. And when you have an ESG framework enforcing a carbon budget, teams are financially and environmentally incentivized to right-size their tools.
Right.
A smaller domain-specific model or even just a traditional deterministic algorithm can often execute a task with the exact same accuracy, but at a fraction of the computational and carbon cost.
It introduces constraints, and constraints drive operational discipline.
Exactly.
I think the organizations that secure a dominant position in the next decade will not simply be the ones that, purchase the most advanced AI capabilities.
Yeah.
The true market leaders will be the organizations that manage the carbon footprint of their AI infrastructure with the exact same ruthless precision they apply to their capital allocation and their supply chain logistics.
Absolutely.
I mean, you would never allow a manufacturing line to run at full capacity just to produce low-value goods.
Right. It'd be a huge waste of money.
Exactly. Similarly, leaders cannot allow massive AI models to just burn through their carbon budgets on low-leverage tasks.
It's about enforcing accountability on a technology that has, frankly, rapidly outgrown its experimental phase and has now become foundational infrastructure.
Yeah, that is a great way to put it. All right, let's pull the key insights together to summarize this deep dive for everyone.
Let's do it.
We started with the central tension, right? The undeniable productivity gains delivered by AI are intrinsically linked to a surging carbon footprint.
Yeah. And we examined the macro projections from Gartner, highlighting that massive 26.4% jump in global data center electricity demand expected by 2026.
Which is right around the corner.
Yep. And the 119.7% rise projected by 2030. And we grounded those projections in the current reality mapped by the IEA, where, remember, up to 10% of national electricity in tech-heavy regions is already dedicated to sustaining this infrastructure.
Which is just staggering. And to manage that reality, organizations must track the full life cycle of their compute costs. You have to understand both the heavy upfront CapEx requirements of the training phase and the continuous compounding OpEx burden of the inference phase.
And finally, we covered the strategic necessity of moving AI into an ESG framework,
Right.
stripping away its status as a technological exception and managing it as a measurable, finite operational input.
The core synthesis of the source material today is that artificial intelligence is simultaneously reshaping two distinct environments.
Yes.
We are so highly focused on how it's reshaping the digital environment, how we work, how we analyze data, and optimize our supply chains. But the sheer computational weight of that transformation is fundamentally reshaping the physical environment beneath it. It's straining national power grids, requiring massive new infrastructure, and rapidly consuming corporate carbon budgets.
And the leaders who are equipped to navigate this era, they're the ones who recognize both realities, the digital capability, and the physical constraint.
Right.
They will integrate the two, ensuring their organizations remain fiercely competitive while simultaneously honoring the strict climate targets they've established.
It's a delicate balancing act for sure, but it is one that's operationally solvable.
Completely.
Which brings me to a final thought I want to leave you with, building on the broader implications of the source material.
Yeah.
If we project this trajectory forward, we are heading toward a physical bottleneck.
Yeah.
Imagine a near-term scenario where regional power grids simply max out their capacity to support new data centers, and those 2030 corporate carbon budgets officially lock into place.
A hard ceiling.
Exactly, a hard ceiling. When the physical constraints of our infrastructure fully collide with the demand for computational power, how will the tech industry respond?
That's the big question.
Will the current obsession with building the absolute largest, most parameter-heavy models hit a hard wall? And if it does, will we see the birth of a completely new competitive race?
Oh, like a race for efficiency.
Exactly. A race focused entirely on engineering the most highly optimized, energy-efficient AI models the world has ever seen. It's definitely an intriguing shift to consider the next time you trigger an automated workflow and initiate another round of inference.
Absolutely.
Thank you so much for joining us on this deep dive. We highly encourage you to take a much closer look at the mechanisms driving those green arrows on your own operational dashboards.